Hey guys, good morning. What's the crack? How are you all doing? It's beautiful weather, which is amazing, right? And GCC results are like what, next week? How's all finding summer school so far? Like good, not good? Results in 9 days. Yeah, it's mad, eh? You're scared. Yeah, I'm sure you all did grand. Like, especially if you're the type of people who are like trying to get ahead in summer school and stuff. You all probably revised loads, didn't you? What do you guys think of the papers? I think they were quite nice this year, the GCSE papers. Absolutely terrified. There's no point worrying, right? Because if you worry, you just go through, you just suffer more than once, don't you? Hey Mimo, hey Mina, hey Aria. I think Aria, you're like first on here today, which is nice. Keys free today? Yes, I am. Why, Aria? Do you have like a sibling that does keys history, or do you also do the keys history lessons? Oh, your sister does them. That's good. How's she find them? She find them good? Hopefully. Amina, you didn't even know it was 9 days. You're just chilling this summer. She loves the lessons. Oh, that's brilliant. Hey Amina, hey Spark, hey Regine. In Search of Sugar's Cat. Oh, is it good? What's the book called? You know, I love the stuff about Schrodinger's cat and about. Have you heard? Maybe heard of like multiple universe theory? Then, Regine, it's your birthday. Happy birthday! Look at you studying physics on your birthday. What a star! Are you gonna do anything special for your birthday? I suppose maybe you do it the weekend, don't you? Or what's the crack? Hi, monkey pickle pants. So we'll start in just about a minute. So your birthday, you're like family get you cakes and stuff. I love birthday cake. I don't know why. You can only buy it like every day of the week, or like it's always in the shops, right? But I've never actually go in and buy cake. I think you just have to wait for the birthday, don't you? Technically, you can buy cake when you want. Obviously, you can. Area, were you not saying you were baking cakes last week? Was that you? I think it was you, wasn't it? Stassy's Park. Sure, you get to spend your birthday with all of us, right? Harry, no way. What's the crack? They turned out amazing. Did you share them with your family then, eh? I can't bake to save my life. I'm atrocious at baking. Okay, so we'll just get started here then. So today, well, you already know me. I don't need to tell you all again, right? So again, love astrophysics. That's why we're talking about Schrodinger's cat a second ago. So good on Regine. But let's see what you remember then. So I know you can't sketch a graph and like pop it in the chat, but if you just try to have a go at it on a piece of paper there and then pop in the chat what you think it would look like. So the first one says, say Bohr throws a ball vertically upwards and he catches it when it comes back down. How would you sketch that on a displacement time graph? So just draw your little axes in your book. Time in seconds, and let's do displacement in meters. And just like roughly pop in the chat how you would do it, and then same for B. Oh yeah, Area, mind you said it was your dog's birthday. My dog, like, yeah, my knees are like proper cut up. So I was showing Holika actually. So I took my dog to the park yesterday, and normally I'm quite good. Like if he goes to go for another dog, I'm not quite prepared for it. But I didn't see that little dog, and the grass was dry, so he took me down, and I skidded all along the park. So my knees are like proper cut up. It looks atrocious, like an adult woman with cut knees. A cooking business. That's cool. Go for it. 100%. Yeah, 100. Yeah, really good job, Area. So really nice job that we're thinking displacement time graph. So I've got someone and they throw a ball up in the air, right? So let's say their hand is 0, right? We're taking that as our reference for 0 displacement. If I throw a ball up, we know what goes up must come back down. And then that is just the displacement there, right? That's the path that the ball is going to take. So there is my displacement time graph. Okay, next one then was Mary Curie drops a ball from rest, allows it to bounce off the ground and catches it at maximum height. So how would you draw a graph for that? So there's your time in seconds, and here is our displacement again. How are we doing that in chat? So again, I got a person. What they're doing is they drop the ball from rest. Okay, so let's take their hand here, 0 displacement. They drop the ball from rest, so it's going to go down, and then they're going to catch it when it reaches maximum height. So it goes down and then comes back up. How would you sketch that on a graph? Displacement time graph. We did this one last day. I just want to see if you can remember it. Because again, just to remind you, so if you look at this one, we know the ball's moving really, really fast at the start. And we said then it's going to start to slow down as it gets to maximum height. And then if we look at this here, we can see, remember, there was 2 options this first part of that graph. Either a curve going like this or a curve going like this. So we're trying to figure out what's happening. Is it A or B? What's happening there? And we said because it's slowing down, we're going to see the gradient to get less steep. So I look at A, that's my gradient getting less steep, right? So that's why it's that section of the graph. Or B, that's something getting more steep. That's something speeding up. That's why it couldn't have been B. Hey, CFK. So then for this one, we're thinking someone drops the ball, right? So if they drop the ball, we know that it's going down. So remember everything we're saying in our classes, if you go down, that's when your negative directions, up is positive. So if it's going down, right, we're thinking as the ball is going down, it's either going to do option A or it's going to do option B. So maybe just pop in the chat for me. So as the ball's falling down, is it going to take the path of A or the path of B? Pop in the chat. So think, it starts in their hand, starts 0 speed, and then it speeds up as you go down. So which one looks something that's going to be speeding up as you go down? Lydia, thanks for starting us off. Area, thanks for starting us off. So again, 0 here, and it's going to speed up as we go down. So A is this one, and B is this one. Oh, we got mixed. So remember, a ball starts in my hand. When I drop it, it gets faster and faster as we're going down. So I'm looking for some curve that's getting faster and faster as it goes down. So I need to get more steep as it goes down. Yeah, Regine, awesome. Ingy, yeah, beautiful. Yeah, beautiful. So it is A, right? So we look at it again. So we'll slow down here a little bit to look at it again. So what we're saying, it has to be A because that's something that's getting steeper as it falls down. So we do it with pen again. So remember we said the gradient of these lines. Yeah, awesome, Chloe. The gradient of these lines is telling us about the speed, right? Okay, but because when something's falling down, we know it's accelerating, right? It's getting faster as it falls down. So as it falls down, I need a curve that looks like it's getting faster. And we said our options were either A or our option was B. Okay, so it's looking at something gets faster. But if I look at the gradient of this, right, that gradient there is not steep, not steep. It's getting steeper, steeper, steeper. So A is something that was getting faster. Whereas look at B, it was really steep at the start, and then it's getting less steep, less steep, less steep, less steep. So B is something that was actually slowing down. So that's why it had to be A for the start, right? Something's getting faster. Okay. Then it says it hits the ground, and she catches it when it reaches maximum height. Okay. Hi, INK, Katarina. So then she said she catches it when it reaches maximum height, right? So now the ball's hit the ground, it's come back up. So now we have to figure out, if I do 2 different colors, that might make things look a little bit easier. Figure out this time when the ball comes back up, is it going to be option A for a ball coming back up, or is it going to be option B for a ball coming back up? So A or B? Which one do you think is going to be the one for the ball coming back up to their hand? If you pop in the chat. So Rajan says B. Amina says A. We'll do it in again. A, B, Evie, thank you for popping in the chat. B. So we're thinking, remember, as the ball's coming back up, Monkey Pigpan says B. So B's seem to be winning, which is good. So it is B. So if we look at it, when the ball's coming back up, right, when it hits the ground, that's when it's going to move in its fastest. And as it comes back up towards my hand, it'll start to slow down, right? Because we've got air resistant things. So it's something fast that's getting slower. So I need something that's really steep gradient at the start, and then something that's got a very low gradient at the end, right? So if we look at B was this shape. That's something that's really steep at the start, and it's getting less steep, less steep, less steep, less steep. So B is something that's slowing down. Whereas A, if you look at it, it's less steep here, and it was getting more steep. So A is something that was speeding up. So that's why it's definitely not A. That's why it had to be B. So maybe just make like a little note of that one. I'm getting highlighter instead of rubber. Maybe like make a little note of that one in your work packs, and then we'll have a go at it again over the next few days. Yeah. Yeah. Oh, area your chat slide. Hopefully, maybe, yeah, sometimes it goes in and out. So hopefully you just have a look at your net. There's a little bit of lag on my end as well. Okay, so now what we're doing today, so the last day we talked about displacement time graphs. Today we're looking at velocity time graphs, okay? So here's all my different velocity time graphs. Can you just pop in the chat what information we're getting from all of these lines? So pop in what A, B, C, D, and E, what information it's giving you, and then if you remember what the definition for acceleration was. So pop in the chat, what information do you think A, B, C, D, and E is giving us? And then pop in the chat. So we're saying, hi, you just joined. No weather, no bothers. Nice that you did join. Chatter G. So Rajin says A is stationary. Do you agree? Monkey Picket Pants also agrees. Yeah, nice for saying stationary. Chatter G, you just missed us kind of reviewing what we did last day. So we were looked at displacement time graphs for someone throwing balls, basically. Yeah, A is just the axis. Good job. So that's why if we look at it, there's nothing here. So that's why what Monkey Pickle Pants there, not Monkey Pickle Pants, was it? It was. And Regine was saying this is stationary, right? It's just stopped. So technically what that is, it's a line across zero. Okay, so S-T-A-T-I-O, I can't spell today, A-R-Y, stationary. Okay, B, we're saying, Lydia's saying a constant velocity. Regine says constant velocity. Yes, beautiful, lovely. So this one is a constant. And then we're going to say positive velocity. Constant positive velocity. Nice. C is something that's accelerating. Good job. Yeah, nice. Just decline. C is a deceleration. No. Do you mean D or just decline? Did you mean to write C there? C is a constant deceleration. Are we seeing C down here? Is my label okay? So C is something that's accelerating. So you see here, it starts off at 0 speed and it's getting faster, 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 faster. So it must be something that's accelerating the whole time. And then D is something that started fast, its velocity is high, and it starts to get lower, 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 lower. So D is our one, yeah, Monkey Picket Pants wasn't, D is going to be deceleration. So D is going to be our deceleration. Yeah, so E I just put here to show you, that one we're just going to call it variable. It's going to be variable acceleration, because it changes all the time, right? I just want to show you that not all, this one you'd never have to do math for. So this one's just for me to look at it. So you'll never have to do math to calculate anything of these ones, but for these ones you do. So just before I pop in the chat, do any of you remember from GCSE, what does the gradient of these lines give you, and what does the area under the graph tell you? Do you remember? What information does it give you? You're in year 11. What do you mean, like you're going into year 11? Or you're going into, you just finished year 11 there and you're going into year 12? Chargy. Acceleration is a change of velocity over time. Good job. Do you remember how to say it? And we were taught last time there was like a word beginning with R. It's better. There's something in change of velocity. So Lydia, it's perfect you said that acceleration is the change of velocity over time, because of what it is. But how do you talk? Yeah, Regine, beautiful. So that's how we want to put it in words. So it is change of velocity over time, but anything over time we say rate. So acceleration is the rate of change of velocity. Yeah, nice. So rate of change of velocity, beautiful. Just decline, good job. Lydia says area is distance, gradient is acceleration. Yeah, good job, brilliant. So what we're saying here, we just said the gradient of these lines, we're going to do math for this today to figure out what the acceleration is. And exactly what Lydia said, if we look at the area under the graph, so I try to find the area under this graph, what I can see here, I'd have to do base times height. So I'd have to do velocity times by time. And if we do velocity times by time, we know that gives us distance, or that gives us displacements. Okay? Because remember, speed equals distance over time. So we did speed times time. That's how I figured out it was a distance, right? Because it's the area under the graph. Yeah. Okay, so we're just going to practice it. So this topic, what you have to do is when you get a graph, you want to try and relay the information onto another graph. So for example, we're going to talk about what this graph has given us, and then we draw an acceleration time graph. Okay, so I'm just going to talk through this one, and then the next one you're just going to have go in your work pack as well. So the first thing I would do is I would look at section A, look at section B, and look at section C. And actually you guys can do it then. What information do we know about A? What do we know about B? And what do we know about C? So just pop in the chat. What is this object doing at A with numbers, right? So remember, we've got numbers now, so we're going to give it some more information. So what is it doing at A? What's it doing at B? And what's it doing at C? And 1V, no worries. I'm glad you joined. A is acceleration. Yeah, Amina, thank you. And then can you give me some data, like some numbers? So A is acceleration, I agree. So we know we're going to have to draw something because we're going to draw an acceleration time graph in a minute. So we know A is accelerating, but we can figure out exactly what it's accelerating at. Yes, Regine, and thank you for writing it like that. Good job. So if we look at it, we said there a minute ago that the gradient of these lines gives us the acceleration. So the gradient, remember, is the vertical divided by the horizontal. So if I look at this line, the vertical there is 20, the horizontal there is 4. So we divide those together, you get 5 meters per second squared. So remember, that's how we have to write it now. Yeah, Amina, beautiful. 5 meters per second squared. And then for section B, I saw someone there put it a second ago, is traveling at constant speed. Nice, and we can give more information on that. We know it's traveling at constant speed of 20 meters per second. Constant speed of 20 meters per second. And then C is deceleration. Yeah, good job. And what number? So what is C's deceleration? Can you give that one a go, Lydia? So it's going to be the change in the vertical divided by the horizontal. Yeah, Amina, beautiful. Constant speed of 20. Lovely. So what numbers would we give for C? So if you look at it, the change in the vertical divided by the change in the horizontal. So it starts at 20, it ends at 10. So the change there in my vertical is 10, and the horizontal. Yeah, Amina, beautiful. Good job. So oh, wait, hold on. -4. You were so close. So the change in the vertical and the horizontal there, it starts at 10 and it ends at 15. So there's my 5. So when I want to find the gradient of the line, it's going to be the change, which is, yeah, just decline, beautiful. So Lydia just missed it, right? Because the change there, if we do final minus initial, it's 10 minus 20 over 5, which gives me -10 over 5, which gives me -2 meters per second squared. Okay, which makes sense because he said it's decelerating, right? So because the word is decelerating, but I'm asking you what the acceleration is, that's why you're giving me a negative number to show me it's not actually accelerating, it's not actually getting faster and faster, it's actually something that's slowing down, right? So if we look at this again, what we've got is, like, let's say it was a car, right? So we've got a car, and what it's done is it's accelerating. So they maybe hit the throttle and they're going faster, 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 and then they go at a constant speed, and then maybe they see a red light ahead of them, so they apply the brakes to try to get them to slow down a little bit. Okay, but they're always still traveling forward. Okay, so when I want to draw an acceleration time graph, the easy way to do it is always to keep your timestamps the same. Okay, so you plot your axes, right? My time is going to be in seconds. This one is going to be my acceleration in meters per second squared. And I'm just going to pop my timestamps on, right? Because that's when things happen. So just pop on 4, pop on 10, and pop on 15, because it's my timestamps all the time. Same things are happening. And then we calculated for the first 4 seconds is a constant acceleration of 5. So I'm going to plot on 5, and we know it's calculated, it's a constant acceleration. For part B, you told me it's a constant speed. So what, in the chat there, what acceleration is that? So for part B, so here's my part A. For part B, what am I going to plot for my acceleration? How would I show it? Yeah, thank you, Regine, right? For 0. So for part B, I just need to draw a flat line there. Thank you, Lydia. Brilliant. Yeah. For part B, I just need to draw a flat line there showing that it's not actually accelerating, right? Yeah, easy, nice. And then for part C, we calculated it was -2. So all I do now is pop on -2 and draw a flat line there at -2. So I can show them that they traveled at -2 meters per second squared for another 5 seconds. Okay, so then that's our acceleration time graph done. So we're just going to practice a few of those today. That's what we're focusing on. Okay, so because we mentioned it a while ago, I think it was Lydia was talking about it, the area underneath these graphs is our displacement. Would you collect lines? Yeah, sorry Lydia, I'll go back there now. you wouldn't do solid lines. So for example, I wouldn't do that. Okay, so I'm just gonna rub that out. So I wouldn't do a solid line, but I would do a dotted line. So you can either leave it blank. I think it looks better blank, but you can do like a dotted line, connect to them. So that's fine too. Yeah, so either a dotted line or just leave it blank. Don't do solid lines because you're not actually plotting information. Yeah. Okay, so what we said here was that the total displacement is what we're trying to find out. No worries, the total displacement. So can you pop in the chat, what is the displacement of A and what is the displacement of B? So just pop in the chat. So what's the displacement of A and what's the displacement of B? So remember, we were saying earlier, I think it was Lydia was saying, it's going to be the area under the graph, right? Area under the graph. So for A, I can see that it's got a height of 20 and a base of 10. Yeah, Lydia, thank you for getting it started. Lovely. Yeah, nice. Yeah, good job. So if we look at it, what we can see here, we've got a height of 20 and a base of 10. So the area under that graph is going to be 20 times by 10 to give me 200 meters. And thank you for popping in the chat there, Lydia. Good job, Regine. And CFK, yeah, nice. So 20 times 10 is what we're doing, right? Nice that you figured out it's meters as well. Because remember the first thing we said last day, you always want to look at your axes, right? I can see it's meters per second, which is why it has to be in meters. Yeah, fab. Okay, for B, what we're thinking then. So we're seeing 20 meters quite a bit. Amina says 20, Lydia says 20. Lydia says 2. So we look at it, we do the area under the graph. So we've got a height of 10 here, a base of 4. So for a triangle, I do 10 times 4 over 2, half the base times the height. So that's going to give me 20 meters in there. And then here, remember we want to do the area under the graph. So I have to find the area underneath that graph there. So it's got a height of 5 and a base of 2. So 2 times 5 is 10. But because we're in the negative part, it's going to be negative 10. So what they did was they've gone 20 meters in the positive direction, then they've went 10 meters in the negative direction. We've got 20 meters positive and then 10 meters in the opposite direction. So that's why our total displacement there is actually 10 meters for this one. Right? So I'll do that one more time. The two graphs, these are just two graphs of us trying to practice finding the area under the graphs, right? So the first graph is just a simple one, right? Where the area under the graph is between the orange line and our axes, the x-axis. So the area under this whole graph here, we just did a height of 20, base of 10, multiplied them together to get 200 meters. But for this one, people keep forgetting, most people, what they do is they take this to be the area under the graph, right? But that's not the area under the graph. That could go on for ages, okay? So what you have to do there is you remember the area under the graph is between your graph and your x-axis. So that's why it was those two regions. And then remember, remember velocity, we said the positives, negatives matter. So remember we said displacement was if I start somewhere and I go for a walk and I come back, my displacement is 0, okay? Because I came back to where I started, because displacement and distance are different. Remember distance, if I asked you the total distance traveled, you would tell me it was 30 meters, because in distance we add them together. But displacement means that you have to think about where you started your reference. So again, if we look at it, so I'll just rub this one out just because a few of you said we're not good with that one. So if I look at this one, we want to find the area underneath the graph, right? So if I look at this one, the area underneath the graph is this triangle and this triangle here. So that I find out what those areas are, okay? So an area of a triangle is half of the base times the height. So the base here is 4, the height here is 10, and I got to divide that by 2. So 4 times 10 is 40, divided by 2 is 20. So that's 20 meters in there. It's the area of that triangle, because it's always in the positive region, right? So what this part here now is my velocities went negative, okay? So if the velocities went negative all of a sudden, because we look at it, it starts at 10 meters per second, something's getting slower, 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 slower. And then what they've done is they started to get faster, but faster in the negative part of the graph. So it's like someone who's turned around. They've got faster in the negative part of the graph. So they got faster in the negative part of the graph. We want to find the area here. So we do half the base times the height. So it starts at 4, ends at 6. So that gives me 2. It starts at 0 and ends at negative 5. So I do 2 times 5, which gives me 10. And then, oh, your math's better than mine. Thank you. 2 times 5, which gives me 10. And then I have to divide that by 2 because it's a triangle. So that's why I get negative 5. Yeah, my math's shocking there. No wonder you're all like, where'd you get negative 10 from? I'm sorry, negative 5. So positive 20 minus 5 gives me positive 15 meters. Positive 15 meters. Can you explain part 3 again? Part 3, that little bit there. Is that what you're talking about, Chatterjee? Because I couldn't do math and got 10 instead of 5. So yeah, that was my bad. So sorry. That's 4 and 6 gives me 2. And then if I look at it again, 0 to negative 5. So I do half the base times the height. So I do 2 times 5 divided by 2. But because it was negative 5, that's why I get negative 5 overall, right? 2 times 5 is negative 10 because it was 2 times negative 5. And then divide that by 2 to give me negative 5. So we went 20 meters in the forward direction. We went negative 5 meters. So my total displacement is a positive 15 meters. And if it asked me for the total distance traveled, that's when it would be 25 meters. So our displacement is the 15 meters and our distance is the 25 meters. Yeah, so Amina and Regine, you guys are perfect. So thanks for fixing that there. And CFK, perfect as well. Yeah, there always is like a little bit of a delay. So there's like roughly about a 5-second between me speaking and your chat. So can you give me like a positive in the chat if we're good, or do you want me to do it again? So like plus, good, happy, minus, do it again, minus, do it again. Right, yep, we'll go again. So if you are good, just do the next one there. And if you're not good, we'll do it one more time. So I'll just rub out again, okay? Okay, so if you are good, just do the next one in your booklet, right? Bear with to rub out. Okay, so maybe we'll talk through what the graph is actually looking like before we do the math. Okay, so if we look at our graph, we've got something that's going at 10 meters per second, right? So let's say we've got a car, and my car is traveling forwards at 10 meters per second because it's a positive number. The car is then slowing down. It's getting slower, slower, slower down to 0. So my car is maybe hit the brakes. He's slowing down, slowing down, slowing down, and eventually he's at 0 meters per second, right? He's at 0 meters per second. And then what they've done here is the velocity now has become negative, right? So negative velocity, because remember our velocity is a vector, the direction matters. Remember last day we said a positive number just means going to the right, a negative number just means it's going to the left. So because our velocity then got negative, what this car has done is a U-turn, and now it's started to get faster in the opposite direction. So my car now is starting to get faster because it was traveling at 0, but now it's getting faster and faster and faster, and now it's going to end up traveling at 5 meters per second in the opposite direction. Okay? So yeah, so what we're trying to say then is, if the car starts here, when it ends, how far away is it from where it started? That's what we're trying to do. So that's why we're trying to find the area under the graph. So we find the area under the graph here. I've got a height of 10 and a base of 4. So I do 10 times 4 divided by 2 because it's a triangle to give me 20 meters. Okay. Then this triangle here, because it's area under the graph, I've got a base of 2 and a height of negative 5. So I do 2 times negative 5 divided by 2 because it's a triangle, not a square. So that gives me negative 5 meters. So I had a positive 20 and a negative 5. So overall, when I have positive 20, negative 5, that's going to give me negative 15 meters. It's going to give me positive 15 meters. That's my displacement. Yeah, so that's my displacement. Yeah, Chatterjee, if you are going into year 11, there is a GCSE summer school as well. But this one, yeah, is more building up from GCSE into year 12s. So thank you all for asking though. Okay, so the next one, if you were good, hopefully you had a look at it already. So for the next one, it says describe the journey as accurate as you can and then find the total displacement for the whole journey. Okay, so we'll start here. So pop in the chat, what's A, B, C, and D? What's it doing at those parts? And then what is the total displacement of the whole journey? Okay, so pop it in the chat. So what's it doing at A, B, C, and D? And then what's the total displacement of the whole journey? Okay, so Amina says it's going to be accelerating for 6 meters per second squared. So nice. Yeah, beautiful. Good job. So here's my 0. So first thing I would do is just mark on my 0 line, right? Because that's where we always usually mark on our x-axis along that 0 line. So the A, I can see I've got a height of 60 and a base of 10. So I've do 60 divided by 10, and that gives me 6 meters per second squared. So we can clearly see A is accelerating for 6 meters per second squared. And 1V, you're going into year 9 and you joined, yeah, this is for year 12, it's your A-level stuff. If you were understand this, you're going to be flying. Amina, a constant speed at 60 meters per second. Yeah, beautiful. Nice. So B is truly traveling at a constant speed, and the constant speed is 60 meters per second to -1. Good job. Lovely. Oh, it's never stationary. No, because look, here the 0 line's here. So it's actually never stationary. This one's just, if we look across at it, do you see the velocity just stays at 60? So it's staying at 60. It's going at a constant velocity. Okay, then Lydia says C is going to be a deceleration of -4. That's why I look at it. It starts at 60 and it ends at 40. So that whole drop there is 100. And I had to see how long it happened over. So we take this line down. That's 15 and that's 40. So that base there is going to be 40 minus 15, which is 25. So all you do then is the vertical divided by the horizontal. And I do 100 divided by 25, and my mental math is shocking. Yeah, good job. It's going to be 4, but it's a -4 because like you just said, Lydia, it's dropping, so it's perfect. So C is -4 meters per second squared. Nice. Yeah, Amina, brilliant. Nice. So -4 because it's dropping, right? We can clearly see the velocity is slowing down, slowing down, slowing down, slowing down, slowing down. And then here it's speeding up in the opposite direction. Yeah, nice. Okay, what about D? We're saying it's accelerating at D. So it's not accelerating D. So if you look at it, D, it starts here at -40, right? So what that means is it's traveling to the left at 40 meters per second. And then what's doing is it's slowing down, -30, -20, -10, 0. So that's actually something that's slowing down. So this one is actually going to be decelerating. Okay, because it's slowing down. And then what we're going to do is we're going to find the change in the vertical. So we can see it's 40. That was nice. So 40 divided by my base, which is 15. So when you do 40 divided by 15, you get a final answer of 2.6 recurring, which is really nice, Lydia, that you changed the number there. 2.6 recurring, which we know we can't write in physics because of what that really means, 2.66666. So I'm just going to round it up to 2.67 or 2.7 meters per second squared. Yeah, perfect. Yeah, nice. Okay, so I'm just going to change colors for the next one. So what's the total displacement here? What's the total displacement? Yeah, and Amina, just be careful. I know you're popping it in the chat just because it's probably easier to write. Just remember in physics, you can't write in fractions. Yeah, so just never write 8/2 or 8/3 is hopefully what you got. You can't write 8/3 because it's a fraction, right? So you can't write fractions in physics either. Okay, so total displacement. And again, if you're having a bit of a mare right now, don't worry about it, right? We're going to do loads of these, right? We've got like another half an hour just looking at these graphs. You'll be pros. You'll be sick of looking at them after. Why can't you write fractions? It's just because it's not numbers, right? So in physics, the only thing you can't do is write recurring decimals and write fractions. So I can never leave it as 100/25. You have to write the numbers out. It's just the rules for marking it. Okay, so what are we thinking for total displacements? Remember, it's area under the graph. So I've marked on my 0 line. So I'm trying to find the total area of all of this beneath the graph. So for me, I would probably, you don't like graphs. Gabriel, you're going to be a pro at them, invented this, I tell you. So for me, I would mark it off. So that's why I wanted to do graph for you guys, because I do think it's one of the, because you do a lot of them in GCSE, right? And in GCSE, they're kind of easy. You always get simple numbers. So I just wanted to make sure that this is a topic that you've done in GCSE and we just want to apply it to like a little bit harder examples. Because the problem is at GCSE, a lot of teachers don't really teach it very well because they teach you, for example, a lot of you probably thought that D was accelerating because it went from -40 to 0. So you thought that was positive numbers because it got from -40 to 0, but you're not that some teachers can't teach that the -40 doesn't mean a more negative number. It means the opposite direction. And that's just like the kind of change you have to get around for year 12. That's why I wanted to focus on this one. Okay, so displacement. Someone be brave. Give it a go. Pop in the chat. So me, I probably split it up into all these triangles, right? So I would start with this triangle and do half the base times the height. So I've got 60 here and 10 here. So I would do 60 times 10. Lydia, straight on it. Good on you. That's brilliant. Wait, yeah, Lydia, what a star. I got the same number. 550 meters. Yeah, nice. Okay, so what I want to do is half the base times the height. So for everybody else, hopefully you're looking here and you're thinking, what I need to do is 60 times by 10 divided by 2 gives me 300 meters. And then for section B, I've got a height of 60 and a base of 5. So all I'm going to do is 60 times 5 to get me another 300 meters. And then for the last triangle there, I've got a height of 60 and I've got a base of 15. So I'm going to do 60 times 15 and then divide that by 2 to get 450. So again, these were all positive, right? They're all positive numbers because it's all in the positive region of the graph. So if we look at this here, it's something that's getting faster in the positive direction, constant speed for 6 meters per second, and then they slowed down and then they did a U-turn and they went into the negative region, right? So really nice that everyone's figuring out it's 550. Yeah, good job, Amina. Good job, Chatterjee. Yeah, awesome. So then we look here, I want to do half the base times the height. So again, if I look right here, my base here is 10, my height here is 40. So I do 40 times 10 divided by 2 to give me 200. And then here, my height is 40 and my base is 15. So I do 40 times 15 divided by 2 to give me 300. So what we had was here, we went 300 plus 300, 600, 600 plus 450 gives us positive 1050, if I can count. Why am I struggling? Where's my pen? Sorry, 1050 is positive, and then the negative was 500. So all we had to do was the positive 1050, take away the 500 to get its final answer of 550. Yeah, easy, right? You're catching on grand. Area, I want to do chem math. Might do 50-50 on tech and physics for A-level because I want to do biochem and math, but I don't want to do all 3 sciences for A-level. Why don't you want to do all 3 sciences for A-level? Might do biochem math. If we don't get the grades for math, which probably won't, might do biochem. Psychology is amazing, but physics, I wouldn't recommend taking without doing math. It's going to be hard because one, if you do physics, and I want you to do physics, I think it's amazing. It opens so many doors. Obviously, I love it, but if you do physics and then you love it, because you will end up loving physics. It's weird. It just gets you, right? Because you're learning the top of the stuff. But by the end of the year, you're going to apply for universities then, and you're not going to get into any universities to study physics because you need to have physics and math for a lot of universities. So like say you want to go to study astrophysics like me, and so you apply to Durham. Durham says on its entry requirements, your requirements, what you need it, they give you grades. So it might be AAA, and it says physics with math. So if you didn't study math with physics for your A levels, you can't go and do that career. So just have a quick look at the universities you might be thinking about or careers you're thinking about, and just have a look, especially if you're deciding between your sciences, right? You want to go see, you were talking about Queen Mary last day. Yeah, so just, I think for medicine, don't quote me on this, but I'm pretty sure for medicine, you just need 2 sciences. I don't think they mind which 2 it is. But chemistry and physics are quite different. Just to sidetrack here a little bit. To get an A star, the numbers are roughly what I'm telling you. It's not like black and white, but to get an A star in chemistry, if you do the OCR spec, you have to get basically 90% to get an A star in the test. If you do the AQA spec with physics, just because my last school taught this, to get an A star, you basically only need 56%. So yes, the chemistry is easier, but because it's easier, the grade boundaries are really, really high. Whereas in physics, basically if you get 56% in AQA, you have an A star. Yeah, chemistry, it was OCR. So I only know these numbers because my last school I taught at was chemistry and physics. But yeah, there is quite a big difference between the grade boundaries between the sciences. Yeah, do math. So if you're taking physics, I just think, like, what's the point in doing 2 years of a subject, right? So physics might not be your favorite subject right now, right? When I was your age, I loved biology. I wanted to be a surgeon, right? And then I did physics for 2 years, and I just was obsessed with astrophysics, right? So I completely changed. But there's no point in you studying physics for 2 years and then you might think you might not want to study it now at uni, but then you might end up loving it like me. And then you'll go to apply to uni, and because you don't have math, you can't go in to study any of those careers. Yeah. It's like careers lesson now, isn't it? Okay, so what are we saying now? Sharji, for finding the total displacement, did you just find the areas of both trapeziums and add them? Yeah, so you can find the area of displacement. Yeah, so you could do half the base times the height. But we have to be careful. What we said about adding them here is I did it with triangles, right? So I found the area of this triangle, area of this rectangle, area of this triangle, and those are all positive numbers. And then I find the area of this negative triangle, the area of this negative triangle. So yeah, we did add them, but technically we subtracted them because it was positive numbers and then there was negative numbers. Yeah. You don't want to do it because you're a teacher. Which subject is having a rough teacher? A bit confusing. Yeah, so what we're saying here again, do you see my triangles? So this triangle here, we said half the base times the height. So half of 10 times by the height, which was 60 there. And then we did a rectangle here, which had a base of 5 and a height of 60. And then we did a triangle here, which had a base of 15 and a height of 60. So those are all positive numbers. And then this region, remember, just don't forget where the 0 is. We took our positive numbers, which are over here, and then you had to take away the negative numbers. Yeah, I mean, it's actually shocking. A lot of schools in the country don't have a physics teacher anymore. So it's quite sad. But then at the same time, like, you hopefully, like you said, if you choose to do physics and you're worried about your teacher and you choose hopefully to do the course for the whole year, you'll have me here as well, right? The second triangle is negative because look at the numbers here. We're in the negative part of the graph. That's why it is negative numbers. Your teacher was mean to you to go for 2 weeks? That's shocking. I have mean streaks sometimes, I'm not going to lie. Maybe she just had a bad day. Oh, yes, that's brilliant. Yes, Charity, it'd be great to have you. Oh, it's really nice to say. Right, okay, so now we're going to get a little bit something new again, and then we're just going to recap it all, okay? So this time we got a velocity time graph, and I want you to draw a displacement time graph, okay? So hopefully in your work pack, you've got a bit of space there. You put time on your x-axis, and you're going to put displacement on your y-axis in meters, okay? Now these ones you can't jump ahead. You got to really take it slow or you're going to struggle a little bit. Okay, so again, remember what we do is we pop our timestamps on, okay? So our timestamps are always the things that are staying the same, 4, 10, and 15. So I got to really think about what's happening in A, B, and C, okay? So in the chat, just really quickly for us, can you pop in what's happening in A, B, and C, and then we'll pop it in the graph. So what's happening in A, B, and C, and then we'll pop it in the graph. A is acceleration, lovely. And then remember we got numbers here, so we can pop numbers in. Area, A is a constant velocity. Nope, careful. Do we see? It starts at 0 and then it's getting faster, faster. It's going to 10, it's going to 20. So something's getting faster the whole time. So it is acceleration. And Mina is perfect. Yeah, good job. So we find the gradient of the line. Vertical is 20, base is 4. So I do 20 divided by 4 to give me 5 meters per second squared. So this is something that started at 0, started at rest, and it's getting faster. It's accelerating at 5 meters per second squared the whole time. Okay. Then we get to section B, and I mean, it's perfect. It's going to travel at a constant speed. And that constant speed is 20 meters per second. And then we get to C, and it's decelerating, right? So we're not saying it's changed direction. We're not saying it's doing nothing like that. It's still in the positive region of the graph. It's still going forward. It's just slowing down, okay? So we looked at this a second ago. It's the same graph we did a second ago. So we already calculated this math when we did the deceleration. The change there in the vertical was 20 and the base was 5. So we're going to do 20 divided by 5 to give us negative 4 meters per second squared. Is that right? Did I do a bad math there? Drops by 20, base of 5. 20 divided by 5 is 4. Yep, negative 4 meters per second squared. Okay, so just to make sure we're good again. So if, let's say it's a car, because it's always easy just to imagine what a car is doing. We've got a car, and what they've done is they've started at rest, 0. So we're starting displacement at 0. And what they've done is they start to accelerate. Why is it 20 and not 10? You're 100% right. My math, sorry, Angel. Thank you for jumping in there. Height of 10, base of 5 is negative 2. Thank you, Angel. I apologize. Okay, so we've got our car. And we said that what she's doing, or her car is doing, is it's getting faster and faster and faster. It's accelerating for the first 4 seconds. Okay. So when I'm turning my displacement time graph, I remember acceleration is a curve. So if it's accelerating for the first 4 seconds, do you think it's going to be option A, or do you think it's going to be option B? Pop in the chat. Which one looks like acceleration for the first 4 seconds? Option A or option B? So Regine says B. Angel says B. Charity says A. So yeah, brilliant. It is B, right? Because if someone's accelerating, we know it's getting faster. Okay, so it's getting faster and faster and faster. So because it's getting faster and faster and faster, I need a gradient of a line that's getting steeper, steeper, steeper. And B is only one that's getting steeper, steeper, steeper. So that's why it has to be B. Okay, so first thing we've plotted there is we clearly know that it is accelerating for the first 4 seconds. So I know the shape of my line is going to be like this, right? But I also need a number on my graph. So can you pop in the chat, what number are we going to pop here? So what is the number that you would pop? What was the displacement in those first 4 seconds? Yeah, just look in the chat there. Totally agree with Garrick. Okay, lovely. So what we're looking at is here, we're trying to find the displacement. So I find the area under the graph. So I do half the base times the height. So I had 4 and I have 20. So half of the base times the height gives me 40, right? So that's why I'm going to pop the number 40 here on my line. Okay, nice. Okay, so then from 4 to 10 seconds, we all said it was traveling at a constant speed of 20 meters per second. Okay. Now we know in a displacement time graph, a constant speed, we do a constant gradient, right? Because remember, the gradient of a displacement time graph gives me the velocity. So I need to get a gradient now that's going to give me a gradient of 20. Yeah, so straight line. Good job. It's going to be a straight line going up, and I need its gradient to be 20. So what height here is it going to end at? So what height is our displacement after those next 6 seconds? So yeah, so what we're doing here is now we're trying to figure out what was that distance traveled in section B. So I can say I've got a height of 20 and a base of 6. I've got a height of 20 and a base of 6. So because it's a square, I can just do 20 times by 6 and I get 120 meters. Does everyone see that there? So the area under this graph, yeah, thank you, Lydia, lovely. The area under that graph there, thank you, Mina. The area under that graph there is 120 meters. So what number am I going to plot here? You pop in the chat. So remember, she went 40 meters in the first 4 seconds. And now we've just calculated at section B, she's traveling at a constant speed of 20 meters per second. So what displacement does she end up at? Yeah, thank you, Regine. Yeah, nice, good job. Because in section B, she traveled 120 meters. So if she already was 40 meters away, and then she went another 120 meters away, she now is 160 meters away. Okay, so she's 160 meters away. Okay, and then you can even check that. We got a height here of 120. We got a base here of 6. So that does give me a gradient of 20. So B is fine. Okay, section C, we said she's decelerating. Okay, so what she's doing here, we just said section A, she's hit the accelerator. She's getting faster, 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 accelerating. She stopped the accelerator and now she's traveling at constant speed. And then here, we said earlier, she probably sees a red light and now she's trying to slow down. Okay, so her displacement is still positive. She's just slowing down. So what displacement is she going to end up at the 15? So what displacement is she going to end up at the 15? You can pop in the chat. I'm just going to make this a bit higher so we can squeeze it all in. 75 meters. Nice. So what do you think her displacement would be? Nice. So what Lydia's saying here is, again, remember in this section of the graph, we want to find the area under the graph. So if I look at that, that's quite a large shape. So I need the area under that graph. So either you could do a triangle and a square, or you could say that it's a trapezium. So let's say we did it was a trapezium. One side's got a height of 20. The other side's got a height of 10. So I add them together, divide by 2, and times by the base. So 20 plus 10 is 30. 30 divided by 2 is 15. 15 times 5 is 75. Exactly what Lydia said. So if she went another 75 meters here, what is her next displacement? So what's my final number I'm popping up there? So what's the final number? So So what's the final number? So hopefully you're thinking if she had went 160 meters, now she's went another 75 meters, she's ended up 235 meters away, right? So yeah, Angel, thank you. Yeah, good job. So her final displacement is 205 meters. And then last question, but I just have a read what you're saying in the chat. We said she's deaccelerating now, right? So I'm going to show you a few options and you're going to pick which one it is in the chat. Okay, so remember, think about it. We just said the whole time she's still traveling forward, she just hit the brakes. Okay, so is it going to be A, or is it going to be B, or is it going to be C, or is it going to be D? Which one is her decelerating? So A, B, C, or D? Which one is decelerating? Angel, easy. Oh, nope, you changed your mind to C. So decelerating. Most of you are picking A. Oh, now we've got a mix between A and C. So decelerating. Okay, so if we look at all of them, A, which nice people figured out, we see the gradient's steep here. The gradient's getting less steep. So A is a deceleration. So it could be A. B is something that's getting more steep. So it definitely can't be B because that's an acceleration. C, if we look at it, is getting more steep. So it can't be C because that would be an acceleration. D is something that's getting less steep. So that could be D. Okay, so we're trying to figure out, do we want something that's going up towards 235 or something that's going back the way? And because remember, we just calculated there and we put it in the chat, we said our final displacement is further away, right? She's still traveling the same way. She's always going forward. She just started fast. Then she started traveling at constant speed and then she started to slow down, right? So because of that, she's always getting further away from us. So that's why we end up with A. Okay, so that's why we end up with A. End up with A. Next one then I'll pop up just while we have read the chat. So this one, can you just, you understand? Thank you, Angel. So this one we're going to talk about now. We want to draw an acceleration time graph and we want to draw a displacement time graph. Okay. So I see some of you are still talking about careers. So how about we finish this one and then I'll go back and read the chat about the careers and then we can talk about it. Is that good? So for this one, again, we'll start with an acceleration time graph because those are quite nice. So can you pop in the chat, what is the acceleration at A, B, C, and D? So pop in the chat, what's the acceleration at A, B, C, and D? What numbers am I going to plot in my graph? What's the acceleration at A, B, C, and D? So many graphs. Yeah, Reggie, that's all today's lesson, the graphs. Just because, like I said, when you learn it in GCSEs, a lot of teachers don't teach the positive negative thing right. And it's very hard to change your mindset then when you get into year 12, which takes a long time. You don't want to be flustered. Okay, so Lydia says the first part is going to be -2. Yeah, perfect. Nice. So what I can see here is at part A, she is decelerating. Okay, so she's getting slower. So if I'm trying to put an acceleration, that's why it has to be -2. So I find -2 in my line and I do a flat line there. So A is -2. Good job. What about B, C, and D? What am I plotting? What about B, C, and D? Okay, so we're saying B is stationary. Nice. So the number is 0. Good job, Lydia. So B is going to be 0 for acceleration. Nice, to 3 to 4. What about C? What's my acceleration there? So 3 to 4 seconds. So 3 to 4 seconds. What's our acceleration here? 4 meters per second. 4 meters per second is a speed. So I want an acceleration, right? I want to know what are they accelerating at between 3 seconds and 4 seconds. Yeah, I mean, they are traveling at constant speed, but I want to know their acceleration. So what's the acceleration at part C? So remember, acceleration and a velocity time graph is the gradient of the line. Yeah, Lydia, Regine, awesome, good job. So it's 0, right? So it's going to be 0 again between 3 and 4. It's not accelerating either. Yeah, nice. It's good job. So then part D, what's my final number? I got to plot my graph. So part D, what's the final number we're plotting our graph? So hopefully we're seeing part D, she's going at -4, and then it's something that's slowing down. So what we're going to get, so the gradient of that line. -2, yeah, easy, good job. Yeah, so I'm going to have my -2 again. Yeah, nice, because she's decelerating. Yeah, easy, good job. Okay, so next one then is displacement time graph. So if I plot my axes, time in seconds, and we're trying to do displacement. Okay, can you pop in the chat, what is the displacement at part A? So what number are we plotting our graph? So I put my time stamps on here, 2, 3, 4, and 6. What is the displacement? What numbers am I going to plot at part A? Yeah, brilliant, Lydia. Nice, good job. So here is going to be my 4 meters, right? Because area under the graph gives me 4 meters. So my displacement is 4 meters. So we just said here at part A, it's accelerating. So can you pop in the chat, is it going to be A or is it going to be B? Which one are we going to plot, A or B, for that first 2 seconds? Which one looks like she is? Yeah, thank you, Angel. Good job, right? Because we just said here, you all told me she's decelerating. So because she's decelerating, it has to be option A. It has to be the gradient of the line that's getting less steep. So the only one that's getting less steep all that time was A. So less steep the whole time. Yeah, fab. Okay, from 2 to 3 seconds, we said that she got 0 acceleration. The velocity is also 0. So what we're going to do with our graph here. So what do I do between 2 and 3 seconds? So we said here, the velocity is 0. So they're stopped, right? They're stopped. So the displacement doesn't change between 2 and 3 seconds. They stay the 4 meters away. Yeah, straight line. Awesome. Yeah, 0 meters. Good job. They're not going to travel any further distance. They're just going to stay where they are. Nice. Okay, what about here? What displacement are we doing for this section of the graph? D is deceleration. Yeah, but we're at C right now. So what about C? Yeah, Lydia, nice. It's -4 meters. Good job, because we're in the negative part of the graph. So clearly we can see here they're in the opposite direction. So we need to take them back to where they started. They went back the -4 meters. Yeah, nice. They went back the -4 meters. Good job. And then now what are they doing here? At part D, what are we going to do for our displacement? The negative part is because we're in the negative region of the graph, right? You can't say that's a positive number if it's a negative number we're multiplying both. So 1 times -4 is -4. So that's why it has to go back -4, has to go back the 4 meters. Because what this person's done, right? If we look at it, they started slow down, and then they stopped. And then what they did was they took off really fast in the opposite direction. -4. Nice, good job. So I can see here, I've got a height of 4, good job, and a base of 2, but it's height of -4. So it's a triangle. So I'm going to get -4 meters. So it's -4 meters. So remember the negative part here. So I'm going to plot my -4, and I need to figure out, is it going to be A? No sugar, we're doing this again. Or is it going to be B? Which one of those is it going to be now? A or B? Which line? The dotted one's B, and my solid line's A. So the dotted one's B and my solid line's A. -4. Did I do bad math there again? So if we look at part D, you can see the height there is -4 and the base there is 2. But because it's triangle, I'm going to find the area under the graph, right? So we do -4 multiplied by 2 divided by 2 gives me -4. A, so we're all saying A. So A is something that's getting less steep, it's going long. So A is something that's slowing down. Yeah, perfect. Easy. Nice. So the last wee part there is going to be A, because clearly it's been slowing down the whole time. It's been decelerating. Nice. Easy. Okay, so yeah, the negative, if we look at it, the velocity, because remember, I think the only thing, Chatterjee, is you're getting lost at here is that they're vectors, right? Negative numbers don't mean more slow, right? So -4 isn't slower than -2. -4 is faster than -2, because the negative just tells us it's going to the left. So it's going to the left at 4 meters per second. It's going to the left 2 meters per second. It's going to the right at 4 meters per second, right? The negative numbers mean direction. Okay. I think what we got time for, we'll probably do 2 more and then we'll talk about the career stuff that I missed there a bit ago. Is that good? Okay, so can someone give me a description in the chat? How would you draw this? It says Chadwick, hopefully you know he is. Chadwick throws a ball vertically upwards. So I've got a person, throws a ball vertically upwards, and he catches it when it comes back down. How do you draw a velocity time graph for that? So there's time in seconds, and there's my velocity. Can you pop in the chat, what would it look like? So he has a ball, he throws it in the air, and it comes back down. So think when he throws it up, the velocity, is it initially really high or is it low? Then what's going to happen to the velocity of the ball? What direction is it going here? What direction is it going here? Why is D deceleration? Because remember, it was -4 going down to 0. If you look at your booklet there. So -4 down to 0. So just go back there a little bit. -4, remember, is not slower than -2. -4 is faster. It means 4 meters per second to the left. This means 2 meters per second to the left. So this person is slowing down. -4, -2, -1, 0. Yeah, you can't send photos. That's why I was going to say if you send me a description. So just starts at 0. Nope. So remember, they throw it up. So when it was a displacement time graph, we did at the very start. Yeah, it looked like this, right? That's my displacement time graph there. It did start at 0. But because they're throwing it up, an inverse parabola. So an inverse parabola, you want me to draw this. So remember, your biggest hint here is, what does the gradient of a velocity time graph give you? Fast acceleration and fast deceleration. So how do you draw? So think about velocity. What is the gradient of it? What's the gradient of it? Yeah, the gradient is the acceleration, right? So the gradient of this line has to tell me about the acceleration. So remember, I've threw a ball in the air. So hopefully we're all thinking the velocity here is really high, right? So the velocity here is going to be really high. We're starting at some really positive number, right? Then my velocity is decreasing. At this point here, the velocity, hopefully everyone remembers, is 0. So at some point it's 0. And if we look here, it's going in the opposite direction, but it's getting faster. So remember, if something's going in the opposite direction, it's going down now, but it's getting faster. So it's going down and it's getting faster. So we're going to end up down here somewhere. And then remember, the gradient of a velocity time graph is the acceleration. And remember, anything that you throw up, once you let go of it, the only thing that's acting on that ball is gravity. So the only thing acting on it is gravity, and gravity has an acceleration of -9.81. So I just need to draw a straight line with a gradient of -9.81. Okay, so let's just talk about this one a little bit more. So again, if we look at it, when they first let go of the ball, we said the velocity is really, really high. That's why it's going to start here. And then look, as the ball's going up, so we're in the positive region of the graph here. As the ball's going up, it's slowing down, which makes sense. My velocity is slowing down. At the very top, the velocity is going to be 0. That little part where the ball changes direction, right? It's not going up anymore. Now it starts to fall down. And as my ball now is falling down, we're going down now. So we're doing negative numbers because we're going down. So now my velocity was 0 here, and it's getting faster. So I need my numbers to get bigger, right? But they're getting bigger in the negative direction because it's getting faster in the negative direction. It's falling back down. And it makes sense then if I look at the whole graph, because the gradient of that graph, but if I ever looked at vertical divided by horizontal, I would get -9.81. Chargy, this could come up in GCSEs, only in triple, and it would be a hard question. But you do need to know velocity time graphs for GCSE, yes. But this would be a hard question, and it only come up in triple. Yes, a hard question would come in triple. Okay, so how are we feeling about this one? Hopefully we're thinking, of course that makes sense, right? Because the gradient has to be -9.81. And I think just today, the main thing what we're seeing here is it just remembering up numbers is positive and down numbers is negative. Yeah, so I'll change color. I think I will do it again. So change color. So what we said here again, remember, when I first have the ball and I throw it up, the velocity is really high, right? It's a really large number. And it's really high positive number because positive, remember, up is always positive numbers, down is always negative numbers. So it's really high positive number because it's going up. But as the ball is going up, it's getting slower. So it's my velocity is getting slower. When it gets to 0, that's when it's at its maximum height. Okay. And then at 0, once it's changed direction, because it's going down now, that's why we're using negative numbers. But as it's going down, it's getting faster, 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 faster. So I need negative numbers that are getting bigger, 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 bigger. So let's say maybe that was negative 10 there. So we can clearly see that it is getting faster, but in the negative direction. And then the gradient of the line always gives us acceleration, and it has to give us number negative 9.81, which is why it's always a constant gradient, right? The only thing acting that ball when you let go of it is gravity. So it's always going to have the same number, negative 9.81. Negative 9.81. Right, how are we feeling about graphs? Hopefully we're feeling a little bit better about them. And I think the only thing about graphs is we did quite a few examples there. You just gotta, Chatterjee, you just gotta practice them a lot with the positive, the negatives, right? Because that's just like we said there, like a GCSE that's taught quite different. And I have seen a lot of physics teachers teach, and because I have to observe it right, and there is the confusion between vectors and scalars. So that's why I remember the first lesson we did here for summer school, we did quite a bit on what a vector and what a scalar was, so that we could get you ready for like trying to think about those negatives and those positives. Yeah. But hopefully that was helpful to y'all. And hopefully, I did want to say this. Do you know I won't be here on Thursday? So you know how we've done our lessons Tuesday, Thursdays? The lesson will be Tuesday, Friday this week, right? So I won't be doing another lesson with you till Friday, because Thursday is results day. So, for A levels. So I taught A levels at my last school there that I've just left. But I want to go back and like see the kids and make sure that I'm there for them when they get their A levels. And I want to know how they did, right? So yeah, so Thursday there will be no physics because I'm doing results day. So it'll be on Friday, if that's good. So if that suits everybody, okay. No, I mean, you're good. I thought, do not say that at the start. GCSEs are 9 days away, was it? Yeah, results day is Thursday for A levels, and then it's the next week for GCSEs. But yeah, you guys are great. So, and thank you as well for asking me loads of questions, right? There's no point. It's really nice that you guys are all, no, stop, do that again. That's really helpful. And I think I missed, let me know if there was a question I missed about the careers that you want me to get to now. Yeah, Charity, do you want to just say it again? Maybe I just missed what you said. Yeah, Area, there were more pages, but just because we spent quite a bit of time. So that page there, that should be in your booklet, was just explaining the graph that we just drew, right? So it's just explaining why it was that shape. And then the only one we didn't do was the little test at the end. So the little test at the end, if you want to do it, like that'd be great. So it's just a little test to make sure you're okay. But just because we had a bit of problem there at the start, so I'd be slowed down a little bit. And the homeworks, hopefully we're still liking and doing it. So Area, yeah, well, next lesson. So if you want to have, see this and this, if you want to have a go at it, next lesson, so on Friday, we'll do the lesson that I've planned, and then we'll do this at the end, right? So we'll hopefully get through his next lesson a little bit faster, and then we'll do this at the end of that lesson. Yeah. Chatterjee, yes, you need to have perfect vision to be a pilot. So, for example, I wear glasses. So, that's what I mean. It depends why you wear glasses. So, I wear glasses because I get headaches when I'm reading screens for a long time, right? Because like we're always reading screens, right? So, or I read a book. If I'm reading a book, I wear glasses because I get a headache. But technically, I have perfect vision. So, I don't wear my glasses when I'm down the street. I don't wear the glasses when I'm driving. I don't need them, right? So technically, I could still be a pilot even though I wear glasses, if you get me. So because if I have perfect vision, but I wear them because I get headaches because I'm reading so much and I just like reading books. So that's more of a question for your I forgot the name. I was going to say eye doctor. It's more of a question for your optician. It's more of a question for your optician. They would know the answer to that question about whether you're wearing glasses because so for example, if you have to wear glasses to drive, which you wouldn't know because you're not driving yet, but if you have to wear glasses to drive legally, then that means that it's unsafe for you to drive without glasses on. So yes, that's the case where you could be a pilot. So just ask your optician whether you have the eyesight that requires you to wear glasses when you drive. And if that's the case, then unfortunately the pilot career is Oh, Garrick. Maybe it's changed. I just was knowing about this because I was trying to be a fighter pilot. So maybe it's different for fighter pilots. So a fighter pilot is like when you, there's test planes because you just want to be a pilot as well. Actually, Garrick, did you just Google it? But I will actually, just because I'm in Neil's room, his office, and he needs it now. Chatterjee, go on, send us a message on, you know, like do you know how we have the TikToks and the videos? Send us a message on there about this, and then I'll get the better information for you. Yeah, commercial is different as well from Air Force. Right, grand. I'll see you all on Friday then. Yes. Thank you for today. You don't use TikTok. You gotta get on there. Right. See you later. See you Friday. Bye.